Right, in section 2.5 and 2.6 notes, we're going to look at some algebraic properties that are going to help us with the first type of proofs that we are going to do. So the first one we're looking at is the reflexive property. The definition is y equals y. If we look at our given or known from the previous step, you can see that if we look at one triangle here, and another triangle, that they both share this segment from A to B. And so therefore, we recognize it because line segment AB is congruent to line segment AB, meaning that it's the exact same on each side of the equal sign. If we look at the second one, we look at the symmetric property, and it tells us if A equals B, then B equals A. And so if we look here, here is our A equals B, and then B will equal A. And so what we are looking for there is a flip-flop across the equal sign. The next one we're looking at is if the addition or subtraction property. If A is equal to B, then A plus C equals B plus C. So if A is equal to B, and if we keep A and B there, we're adding C to both sides of the equation. And that'll keep our equation equal. So if we look at the example here, we would then, since this is addition or subtraction, we subtracted 5 from both sides, transformed the equation in there. And remember that what we're looking for here is that we're able to add or subtract from each side. Okay, what that means is that, as we learned a long time ago, that both sides of the equation change. Our next one is to be able to multiply or divide, the multiplicative or division property. If we start out with something that is equal to each other, A equals B, we can multiply or divide both sides by the same constant, and both sides of the equation will change but still be equal. So if we look at the example here, if we take and divide both sides by 15, we would get x equals 3. So this tells us that we can multiply or we can divide each side of the equation, and that both sides of the equation change. Our next property is the distributive property, and it tells us that if we have a number or variable on the outside of the parenthesis, we can distribute or multiply that number or variable times the contents of the parenthesis. And so we're looking at being able to distribute that 3 times the quantity x minus 5 to become 3x minus 15. Notice that for this one, that only one side of the equation changes. and that we distribute over parentheses. Okay, our next one is our substitution property. If we start off with A equal to B, then A may be replaced for B or in any equation or expression. So if we look at our example, if x is equal to 4 and 3x plus 5y equals 8, what we can do is if we look at that x is 4 and there's an x here, that means that we can put in 4 in place of x. So this one looks a little bit different because we must have two givens. That was our if x equals 4 and 3x plus 5y equals 8. And those two givens must combine to make a new statement. If we look at the next one, this is our transitive property. It tells us that if x is equal to 4 and 4 equals 3x plus 5y, then x is equal to 3x plus 5y. So if we look at this, if we know that if x is 4 and 4 is equal to 3x plus 5y, then the conclusion that we can draw here is that x is equal to 3x plus 5y. So once again, for this one, we must have two givens. And we must have one side of the equation, one side in each equation must match the other. And so we have one last algebraic property that we want to look at that is on the next page. And that is for simplify. And our description here, if a plus a is equal to c, then 2a equals c. And so if we look at our given, we can see that 5x plus 3x simplifies to 8x. So when we look at this, only one side of the equation changes. And what we were doing there is combining like terms.